All right. Those who are listening at home, hello. If you join us in 5 minutes, we'll adapt. Let's pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Confiteor, Deo omnipotenti, et vobis Patris, qui applicabilis potentatione, verbo, opere, et omissione. Mea culpa, mea maxima culpa, et io precordiatam meam sacerdote, omnes santos et sacerdotes, et vos, fratres, orate pro me, ad Dominum Deum nostrum. Amen. In nomine Patris et Filii et Spiritus Sancti. Amen. All right, take out your Lewis 7b-3. Let me switch it out. Oh, right, yeah. Okay. Okay. Righty. Let me read off the answers. We are as
Yeah, me too. This is a hard
number 1. You should have, these are all simplified. So negative x cotangent of x plus ln of sine of x
one.
plus c. You want me to repeat? Okay. Number 2, I'll tell you the best choice for u and dv, and then I'll give you the answer. The best one for u would be ln of x, which is surprising. Hark! I do. Just a second. We're recording this one, good.
The camera missed like half of that.
I think you got it.
Okay. And number 2, so the u would be ln of x, dv would be 1 over radical x dx. That's a little surprise.
1 over radical x.
So you could have radical, or x to the negative 1/2, I suppose. But that was tricky. Normally, you figure it's either going to be ln of x or just radical x as the pieces. But 1 over radical x is legit. That's a curveball. So if you can get that one, don't feel too bad. Just store it for future reference. So your final answer should be 2. Oh my gracious, hang on a second. We're pretty like grandmother coming in to visit. Just leave the door cracked, so just 500 other people. So the final answer should be 2 radical x ln of x minus 4 radical x plus c. If you left it as 2x to the 1/2 ln of x minus 4x to the 1/2 plus c, that's okay. Yeah.
I had to see.
Do you want the x to the 1/2 version or the radical x version? Okay. So 2 radical x ln of x minus 4 radical x plus c. Number 3. This one is a teeny bit weird because it has a weird base.
Yeah.
So the integration by parts wasn't too horrendous, but the weird base does have an interesting spin. The best thing to use, if you don't believe it or not, this is one of the few times I've ever seen this. U equals x, and then dv is equal to 2 to the x dx.
Sweet.
So because du becomes really easy. Final answer should be, there are a couple ways to write this. I wrote it as 1 over ln of 2 times x 2 to the x. You could also have x 2 to the x over ln of 2, that's fine. Minus 2 to the x over ln of 2 parentheses squared plus c. And we need the root. Number 4. The easiest one to use is u equals ln of x, and then dv is radical x dx. Your final answer should be 2/3 x to the 3/2 ln of rest of the three out just do x, rest of x. Do the rest of x. Any repeats on that one? Quite sound like it. No.
I think that was Emma.
I haven't memorized, I don't remember her flip-flopping down the road. Yeah.
It's usually either Miss Moore, Mrs. Moore, or Miss Moore.
Oh, that's true, yeah. And I'm being recorded here, so I gotta be careful what I say. But there are people who are very distinctive walking down the hall.
Miss Moore is so loud.
Yeah. Number five, this is a little bit on the weird side. U should be the entire thing except for dx.
What? You had that?
If you tried u equals x squared plus 1, it would not work.
Every single time, but I'm still failing.
I tried it.
Yeah.
So it didn't work.
I got all the right like use
Yeah.
and stuff, but I didn't know what to do with it.
Yeah.
Okay.
It's like,
Yeah,
oh,
that's
boy.
bad.
And then dv should be dx. Your final answer should be x ln of x squared plus 1 minus 2x plus 2, wait. Oh, come on. I want to take this program and slap it. We didn't cover an element in the answer. It was in today's assignment. And Weasel Computer here decided to throw it in anyway. Number 5, just scratch off. Because part of the answer is the
Oh,
inverse
Kara still
tangent
got it wrong.
of x. And I was going to teach you how to do that today. And he said, oh, it's okay if I do something that they don't know, right? No, it's not. All right, moving on. I apologize for number 5. That was awful. Number 6. You should have used u is the entire thing. By the way, there are 2 ways to do this. You could have used plain old u substitution for this one. Or you could have done u is the whole thing except dx. And then dv is equal to dx. This is kind of like the one we did on the board. Final answer should have been x ln of x plus 1 minus x plus ln of x plus 1 plus c. And number 7. The ln's have this, you can't pull the 2 out in front, unfortunately. They're, the best thing to use, well, the quickest thing to use, I'm not sure if it's the best, is u equals ln of x parentheses squared, the entire thing except dx. That's actually a very common thing to do when ln's are in there. And then dv is dx. Final answer should be x times ln of x parentheses squared minus 2x ln of x. Now that they use a log rule to simplify. Plus 2x plus c. Any repeats on any of those? All right.
Anyone who like.
Go for it.
Seriously.
So which one?
Anyone.
Any one of them? Yeah, I figured this one was kind of intense.
This worksheet was just.
Yeah.
You know.
On the task, if it makes you feel any better, I'm not going to do these quite so intense. This is sort of a build up your mental muscles so that when the test comes, it'll seem pretty easy. Are we ready? Are we on?
Oh, I guess you're on one.
Okay. The integral of x cosecant of x square root of x dx, I think. Yeah. They're suggesting u is equal to x and dv is equal to cosecant squared of x dx. Now that's actually pretty logical. Does everybody recognize cosecant squared?
Yes.
Where did it come from?
Cotangent.
It's the derivative of
Negative
negative cotangent. Right, why negative?
because the derivative of cotangent is negative cosecant squared.
Right. If it were, the derivative of cotangent is negative cosecant squared. So the derivative of negative cotangent is regular cosecant squared. So this must have come from negative cotangent of x. So what's du? Oh, it's right.
Oh, dx.
dx, right.
Sorry.
Now, the formula, this is u dv. So it should be uv minus integral of v du. So u is equal to x, v is equal to negative cotangent of x, minus the integral of negative cotangent of x times du dx. Now that's going to be a little bit of a pain at the end. The nice thing about that is this part's done. It's just negative x, I just pulled the negative in front because it's a constant, of x. Minus a negative will be kind of nice, I'll just do plus. The integral of cotangent of x dx. How on earth do you do that? We do not know that as an elementary antiderivative. Any idea? Well, people who might remember what we call master formulas from trig.
No.
What is cotangent to a definition?
One
Or two answers to that. One over tangent, and there's another one.
Cosine over sine?
Cosine over sine. Right. So it's negative x, cotangent of x, that'll just stay put forever, plus the integral of cosine of x over sine of x, and the dx is on top. What would you recommend? Put that integral in the end. All that people.
You have to substitute?
Right, we've got basically 4 tricks in our integral tool belt. One is plain old power rule, where you do the raise the power divided by the power. That's a polynomial. Second thing is trig. If you happen to know the 6 trig functions and their derivatives, you can go backwards. The third is substitution, and the fourth is integration by parts. This is a substitution problem. So we did the integration by parts to get the icky thing out of the way. Now, if you do u equals sine of x, and then du is cosine of x dx. Is that line right anywhere?
Yes.
It is. So this thingy, let me put it here. Just not that, but oh, I remember. This is the integral of basically 1 over u times du. You can just kick this off to the side. What is that?
ln of u?
ln of u, correct. So let's do that. Put it in here. So it's negative x cotangent of x plus ln of u plus c. What is u?
Sine of x.
Right. So negative x cotangent of x plus ln of sine of x plus c. There you go.
Right.
So it's a 2-step problem.
Yeah.
Integration by parts, you got the product rule thingy out of your antiderivative, and then this needed substitution. And it was tricky because cotangent doesn't immediately look like a fraction. You have to make it a fraction. Did we go with that?
Yeah. Number 3.
Mm-hmm.
3.
Mm-hmm.
Trace.
Emily, number 2?
Or 2.
Okay.
You just do all the odds.
Should I just do more?
Yeah, seriously.
Okay, sure. My markers are dying too, which is kind of poetic given the problems here. The integral ln of x over radical x. Dx. Now, there are a couple of things we could try. Here are the 2 possibilities. U equals, well, there are 3 possibilities. U equals ln of x, and dv is equal to, if you tried this, watch what happens. The u actually works pretty well. What's du?
We don't know.
What's the derivative of ln of x?
1
I
over.
wanna
1 over x.
Yeah.
dx. What's the antiderivative of this? Let me rewrite it in antiderivative friendly form.
So x to the negative
Another way.
2/3.
Raise the power and then divide by
2/3 x to the 3 halves.
2/3 x to the 3 halves plus c, basically. Now check it out. Is that line going anywhere? No. It looks like we could try. Is this UV? Well, let's try it. Just try and rewrite it and see if it, like, put the U and the dV in there. It looks like this would be U over dV. Does anybody see a problem with that?
Maybe not have the thing in the bottom.
The what thing? Do you remember the name for it? The D whatever?
Derivative, or, the
DIF?
differential?
Differential, good. Differentials can never be in the bottom, correct. This is bad. And as a matter of fact, there's two things wrong with it. There are two differentials in the bottom. It'll be a dx and a dv,
Oh, well.
so it'd be a double whammy. So this is a total disaster. But this looked so good. Say, well, let's just try it the other way around. Well, if you use this as dv, you'll have to take the antiderivative of it, which we did do a couple of times ago using the integration by parts. But if you have to use the integration by parts in order to get the first part of integration by parts, that can cause issues. There's one other thing, and it was hard to see. U equals ln of x, dv equals, it looks like an L, which is really awkward, 1 over radical x dx. So if you wrote this like this, it's the exact same problem, but maybe this will work. du is nice as it was last time. V is, now remember, this is x to the negative 1/2 dx. Take the antiderivative of that.
Is that x to the 1/2? Or no?
Yeah, new power is 1/2, and then
Yeah.
divided by 1/2.
Yeah, so 2. So 2x to 1/2.
Right. Let's slap this into integration by parts and see what happens. So we've got the integral of u dv equals uv minus the integral of v du. Recreate this for me.
So ln of x
Ln of x
times 2x to 1/2.
times 2x to 1/2. Okay.
Minus the integral of 1 over radical x. Or no.
Regular
Yeah,
v.
2x to 1/2
2x to 1/2
times 1 over x dx.
times 1 over x dx. Does anything reduce or otherwise change?
Well, the derivative does.
Yeah, I mean, this thing just stays put. This is 2 radical x times ln of x minus, I'm going to pull the 2 out in front. What's x to the 1/2 over x?
So 1 over x. Oh, it's negative x to the negative 1/2.
X to the negative 1/2. And that you can do. Go for it.
So it would be
2 radical x ln of x minus 2 times what?
it'd be so it'd be x.
What's the new power?
It'd be x to the 1/2
X to the 1/2 divided by
divided by 2, so 2. Or no,
Divided by
1/2.
1/2. So
That'd be
2 x to the 1/2 plus c. Give me the final thing.
Then that first term.
So 2 radical x times, it doesn't matter where you put the
Yeah.
parentheses. As long as the ln of x doesn't look like it's getting square rooted. Minus what?
Minus 4x to the 1/2 plus.
What is this really? You don't have to
Oh,
change
radical
it.
x.
4 radical x plus c. There you go.
That's fun.
Yeah.
And you can leave those as x to the 1/2. So I'm not going to be persnickety on that. Okay. Number 3?
Sure.
Okay. Number 3, x, integral of x times 2 to the x dx. Just to refresh my memory, does anybody happen to know the derivative of 2 to the x?
2 to the x? Or
Sort of, that's true.
2 to the x
It's
plus c?
largely immune to derivatives. There's a price to pay for the weird base.
Ln of 2.
ln of 2,
What about that? Shoot.
and then dx. So what's this? What's the antiderivative to the x? Part of it's the same.
Well, it's 2 to the x
Yeah, it's immune to derivatives and antiderivatives.
plus c. Or,
When you take the derivative, you multiply by the weird power, the
Oh, you
weird
divide by
price
it.
of x. You divide by it. Do you understand?
yeah.
So keep that in the back of your mind. There is a weird price to pay. If you take the derivative, you multiply by ln of 2. Take the antiderivative, you divide by ln of 2. So, any recommendations? What's the rule of thumb for when you pick a part? Like when you pick the u and the dv, what should happen? The two parts when you play with them,
And when you play with them, they should look nice.
they should look nice, or at least not worse.
Yeah.
If they get worse and worse and worse, stop and do the other way around. So I could either make this u, or I could make this dv. Just by itself, what would you recommend? Which would make it look better?
U equals x.
U equals x, correct. If I did dv equals x, I'd have to take the antiderivative, which is not horrible, but it goes to 1/2 x squared. So it makes it look worse. If I do u equals x, which I normally never do with substitution, it's just dv. What would dv be if you did that?
2x.
To the
2x
x,
dx.
dx. What's du?
2 dx divided by ln of x.
I mean,
Oh no, sorry, dx.
dx. And then what's the antiderivative of this?
It's 2 dx over ln of 2.
Of 2
Let's see.
plus c, and then the plus c will be put in. You can write this also, you can pull the constant out front. Still leave you. Either way is fine. Let's do into our rule of integration by parts. So this is u. dv equals what?
So it'd be x times
Yeah, u, v. So what is that?
x
X
times
times,
2 dx
yeah, to the x over
to the ln of 2
ln of 2. Minus the integral of,
rule of x. Or no.
to the x
X
over
over
ln of 2. So v du. And what goes here?
and then dx.
Yeah. Okay. Oh, this is ln of 2. Alright, my fault. This is a constant.
Pull it up front.
Pull it out in front as long as you keep it on the bottom. How do you do that?
1 over ln of 2.
Put a 1, yeah. So it looks like this. This becomes, I'm going to pull this in front too because it's annoying. 1 over ln of 2 times x times 2 to the x power minus 1 over ln of 2 times the antiderivative of 2 to the x dx.
Oh wow.
Tell me what to do.
I'll say the same, right?
Yeah, this is x times 2 to the x, that's done. Minus 1 over ln of 2 times what?
Times 2 to the x.
It's the same thing we've done
Yeah, with ln of it.
over ln of 2.
Okay, yeah.
So what happens here? You can pull this out in front as well.
ln of 2x squared.
ln of 2 parentheses squared, yeah. It's going to be 1 over ln of 2 times x times 2 to the x. Minus, it'll be 1 over ln of 2 parentheses squared. Make sense? Because I pulled another ln of 2 out front.
You have 2 to the x on top. or you-
Yeah, 2 to the x on top or to the side, doesn't make any difference.
There you go.
And then plus c. And that's it. And that's it, he says, this is falling off the wall. It's not. This is pretty intense.
You make it look so easy.
Well, I'm glad. Part of it is that the choices of u and dv were not obvious in this worksheet.
Yeah.
Some of the things would have scared us away. The things that would not have worked with regular substitution do work with integration by parts because there's a DV that comes to our rescue. So, welcome to the, normally, the idea of guess and check, I don't even dignify it with the word method, because it's considered, like, I don't want to say it's what wimps do when they're desperate, but it sort of is. But here, we have to guess and check. That's every mathematician in the world has to guess and check. Integration by parts is just try this, and okay, it didn't work. A typical integration by parts worksheet or homework assignment is going to have at least one or two trials that did not work. That's just what happens. So it's not that you're doing anything wrong, it's that the silly thing is not easy to do. Next. Or just keep going.
Sure. Yeah.
All right. Yeah. Number 4. The integral of radical x ln of x, is that right?
Yeah. Yeah.
Okay. Now, does everybody, can everybody tell me why, aside from the fact that it's in the worksheet, why would integration by parts be a possibility for us here? Why would you think it's necessary? When do you use it?
When you can't do substitution.
True, and there's one specific case where integration by parts works.
Is that a product rule?
Product. If there's two functions that multiply together, then you can't simplify them. And if those are x squared and x cubed, just mush them together and do a regular problem. But you can't do that here. And regular substitution doesn't seem to work. So, what would you recommend? Good choices. Let's talk this through. There seem to be 2 parts. And now, I will argue that there were actually 3. You could do, like U could have been this part, or this part, or this entire part. Does that make sense? There are 3 different possibilities there. Dx could be by itself. I would recommend that it would be here.
Yeah.
Taking the derivative of dx is kind of scary. We don't really know how to do that. But taking the antiderivative of dx is easy. You get x. So, what would you try first? I'm looking at the ln of x. What do we not want to do with that if we can avoid it?
You don't want to do that through the dv.
Yeah, we don't want to antiderive that, because the antiderivative of ln of x does exist, but it takes its own integration by parts to do it. Well, we'll if we have to, but, so what might be a good candidate?
ln of x
Yeah, for what?
for you.
For u. What does that make for du?
1 over x
Right, 1 over x
dx.
dx. That at least was relatively easy. If that's true, then dv would be what?
Radical x dx.
And then switch that to antiderivative friendly form.
X to the 1/2 dx.
Right. Now find v for me.
Yes.
What's the new power?
3 halves.
3,
Oh no, it's negative 1/2. Oh yeah, 3 halves.
3 halves. And then
And then you divide it by, then it's 2/3.
2/3
X 3 halves.
x to the 3 halves dx. Or what plus c, that's my fault. And then plus the other again. Agree with me so far?
Yep.
Okay.
Then you do the product or
Yeah, the integration of parts. So UV minus the integral of V du. So what goes here?
ln of x,
Mm-hmm.
and then 2/3 x to the 3 halves,
2/3 x to 3 halves minus the integral of
and then 2/3 x to 3 halves,
2/3 x to 3 halves
times 1 over x dx.
times 1 over x dx. Does that make simplify?
Yes.
How so?
The x's are gone,
Yeah, one of the x's will cancel.
so it's x to the 1/2.
It's x to the 1/2. Let me rewrite that. So this whole thing is 2/3 x to the 3 halves ln of x minus this thing. I'm going to pull the 2/3 out in front of that. And it's 2/3 times the integral of x to the 1/2 dx. Go for it.
Okay. Then that equals you already did that, 2/3 x 3x.
Yeah, that's 2/3 x to the 3 halves. So it would be 2/3 x to the 3 halves, ln of x, minus 2/3 times, the antiderivative is 2/3 x to the 3 halves plus c. It's plus c in here, but yeah.
Yeah.
Squish them together. 2/3 x to the 3 halves, ln of x, minus 4/9 x to the 3 halves plus c. Ready? Oh, there's a moment.
Mr. Cochran has ruined our day.
I know. That's why. If only Mr. Geigen had caught his marker, this worksheet would have been awesome. But as it was, it almost destroyed our brain cells. But, yeah.
That's enough, 4 problems.
This is the no problem. What was the next one?
So it's gonna be number
Number
5.
5?
Oh, we skipped these.
Oh, we skipped number 5. Never mind. Yeah.
Right.
Yeah. And that's just adding insult to injury. So number 6. Everyone see that one?
Yep.
Okay. It's very similar. The integral of the quickest way to do it, ln of x plus 1 dx. This one, if you actually use substitution,
If you substitute the whole thing. Right?
u equals x plus 1, du equals dx. There are 2 ways to do this.
Okay.
You could substitute the whole thing for integration by parts. But take a look at what this looks like. That's the integral of ln of u du. Now, if you happen to know what the answer to that is, now, I'm not 100% sure if anyone remembers this. The integral of ln of x dx. We had to do integration by parts in order to get this done. It was x ln of x minus x plus c. If you want to memorize that, that might come in handy. Because if you did, you could do u ln of u minus u plus c, and you got just plug u back in.
Yeah, that'd be super helpful.
So the x plus 1.
So you could do substitution. You just have to-
Correct.
you just
If you happen to know that.
So you basically, you can do both of them, substitution and integration by parts together, yeah.
Right. Now, if the regular substitution doesn't cure the problem, if you don't have this memorized.
Right.
How would you do the natural log antiderivative? You got to do integration by parts on this.
Yeah.
So you can't really escape integration by parts on this problem unless you have the answer memorized of plain old ln of x. Again, you don't have to, but if you do, let's just say u equals ln of x and dv is equal to dx. So du is equal to 1 over x dx. And then v is equal to x. And then you just do the do the integration by parts, and you'll get this. It's relatively straightforward. So it's not a tragedy if you don't memorize that. It'll take another minute and a half to get the answer. Questions on that? Alrighty. I think they just simplified a particular thing you did. Yeah, the worksheet is this. You notice there's an x plus 1 in both of these?
Yeah.
They factored it out.
Oh.
And they had an x plus 1 in the front, then ln of x plus 1 minus 1.
Actually, if you knew that, if you know that, or I think it takes like 5 seconds.
Yeah, if you haven't memorized, it's very fast. If you don't, last one. I just have this mental image of Emma sitting at home, watching the screen, and just shaking her head, and just disbelief, just this sort of expression of, he's not serious. Like,
Yeah.
He's not expecting us to, like, Mr. Geigen, have you been replaced by an imposter or something? No, this is just a particularly annoying section. I will, after we're done with this, I'm gonna give you what would be a typical integration by parts problem, just so you can calibrate your brains.
Okay,
These are relatively intense integration by parts problems.
good to know.
They're supposed to be. They build up these mental muscles, so that when the real ones come, it's not gonna be so stressful. The integration of L of x parentheses squared.
Yeah, I got you.
Yeah. Now keep in mind, the integral of ln of x squared dx would have been very different. This, you can pull the 2 out in front, and all the way out in front, which would be relatively easy,
Yeah,
especially if you have this memorized. It'd still be integration by parts, but it's almost awful log integration by parts. This, not so much. I cannot pull the 2 out in front. So, any suggestions?
can you substitute?
I know, there are 3 possibilities for substituting. You could have u equals what?
ln of x.
ln of x,
ln of x squared.
ln of x squared,
ln of x squared dx.
ln of x squared, yeah. Or you could just have dx.
Sorry, just dx.
Now, which would be horrible, because taking the derivative of it, bad. But, so I would kind of throw that one out. There seem to be 2 possibilities. U equals ln of x. Let's try that. U equals plain old ln of x. So what would dv be? What's left? Look carefully. It's messy. Let me write it
Oh, yeah, what?
like this. If you have u equals ln of x, what does dv have to be? Without leaving an orphan behind.
Squared?
ln of x dx. The other part.
Oh. Oh, yeah.
That, I don't think will end well. Could you do that? Yeah, you have to take the antiderivative of this, and the derivative, maybe. Yeah. Oh, yeah, definitely. No, I'm not taking this personal. That's okay. And so this probably wouldn't work. So the only other possibility, u equals ln of x quantity squared, and then dv is just dx. If that's true, what's v? Let's get the easiest part out of the way.
X.
Should be x. How about this thing? You'll need the chain rule. Blah squared.
Oh, yeah, shoot. What of x?
2 times blah to the first power times the derivative of blah.
What of x?
1 over x dx. So what should I put in here?
ln of x.
Yeah. Looks a little messy, but yeah. It's life. So it's now u, v minus the integral of v du. So something minus the integral of something. So fill in the thingy.
ln of x squared.
Yeah, ln of x squared.
And then, x.
X. And now when you're just done.
Yeah, what's next? And then x.
X.
And then dx.
And then
No.
du would be.
Oh, yeah. Right there.
Oh, sorry, I didn't even put that.
Yeah. It's there, guys.
It's there, real beyond it.
That whole thing.
It's true. Yeah, it's 2 times 1 over x times ln of x. Does anything simplify?
Probably. Yes, that's the x is.
The x is canceled, glory be to God, and the 2 pulls out front.
Oh, so nice.
So it looks like this, equals x ln of x minus the integral of ln of x
We'll figure the square.
dx. Oh, so. And then this, if you haven't have it memorized,
And there's the 2 also.
ln of x, parentheses squared, oh, thank you. Save my bacon, minus 2 times
And then the.
x ln of x minus x plus c in the end. And then just distribute. X times ln of x parentheses squared minus 2x ln of x minus 2, or plus 2x plus c. And that. Do it.
Boom.
Yeah.
Yeah.
All right. Yeah. Now, let me give you an idea of the type of problem that I would give you on test.
Okay. Let's see it. Holy moly, it's almost April.
Try that.
Well, like yesterday, that was for the first week.
Yeah.
What would you recommend? First of all, the structure suggests we need what technique?
Integration by parts.
Why do you say that?
Because it's a product and can do substitution.
Yeah, it's a product, and just regular old substitution doesn't seem to work. By the way, feel free to try regular substitution. There's no honor lost in trying that.
You have to pull an X and an E out of nowhere.
Yeah, regular substitution would have to be the input. The furthest in layer is 2x. So you do u equals 2x, and then du is 2dx.
Where we need an E.
Yeah, and the e is a constant, so it's not a big deal. But regular substitution doesn't work on this. So I've got u dv. What would you recommend?
U equals X.
That's logical. Why?
So then it's just dx.
du is very easy to get. And then dv, what would that have to be?
dv would be e to the 2x dx.
Yeah. So what's v? By the way, what's the antiderivative of e to the x?
e to the x.
E to the x. What's the antiderivative of this thing?
e to the 2x.
Oh, by the way, remind me, what's the derivative of e to the 2x?
That's e to the 2x.
It's e to the 2x times
dx. Or,
Ln of 2x.
chain rule.
ln of 2x, yeah.
Ln is when you use weird bases.
It's
So e to the 2x times,
oh shoot, what is it?
here's the input. Chain rule. The derivative of 2x is
Oh.
what?
Q?
2.
Well.
Remember that?
So then you divide by 2?
Right. So if taking the derivative multiplies by 2, taking the antiderivative divides by 2. Does that seem kind of familiar?
Shoot. Yeah, I need to come up with that.
Let
Okay.
me just drill on that. That's a useful thing too. Oops, I'll pick that up in a minute. Just so you remember. Got what's the derivative of e to the x? Plain old.
E to the x.
E to the x. Remember that? Yeah. And then the derivative of e to the x squared plus 5x plus 6.
Oh my. It's e.
It's going to be e to the
E to the that.
x squared plus 5x plus 6
Times 2x plus 5.
x plus 5. Yeah. That's the chain rule working. Try this. What's the derivative of 2 to the x? It's very similar. 2 to the x, but there's a price tag. Right?
Oh, that's the ln of x.
That's the ln of 2. Technically times 1, because the chain rule is still working, although it's boring in this case. Then the derivative of 2 to the
2x.
x squared plus 5x plus 6.
Would be 2
2 to the
x squared.
x squared plus 5x plus 6 times ln of 2 and then times
2x
2x plus 5.
So it's just a big chain rule.
Right. The chain rule always works, but with a weird base, you have an extra step. You put that extra punishment there. So now if you go backwards, let's try this. What's the antiderivative of e to the x dx?
E to the x. Yeah,
That's it.
that's it.
Plus c.
Plus
Now, this is going to be a little tricky, but the antiderivative of e to the x squared plus 5x plus 6 times 2x plus 5.
Well, that's just e to the x squared plus 5x plus 6.
Yeah. You would do a substitution problem to get this. U equals x squared plus 5x plus 6. And then du is 2x plus 5 dx, which is up there. So it's really the e to the u du, which is e to the u plus c. Yeah, so that's what we're finding. So down here though, what's the antiderivative of 2 to the x? dx.
2 to the x.
2 to the x still.
2 to the x divided by, wait, divided by? No.
Oops, yeah. Oh, divide.
Divided by ln x? Or ln 2, ln 2.
ln of 2. And technically
Ln 1.
divided by 1, because the chain rule. Plus it. Let's go back over here. The derivative of e to the 2x is e to the 2x times 2. The antiderivative is e to the 2x divided by 2. Making more sense?
Yeah.
Okay. Let's put it into a u v minus the integral of v du. So what goes here?
It would be
X.
x, yeah. 1 half
1 half e to
2x.
the 2x.
And then 1 half e to the 2x.
1 half e to the 2x.
E to the 2x dx. Or, no, I don't want
Then-
dx.
dx, correct. I'm going to pull a 1 half in front. So this is going to be 1 half x e to the 2x minus 1 half times something. The antiderivative of e to the 2x, which interestingly enough, you did earlier. You just
Yeah,
need to do it again.
that's nice.
So what is it?
1 half x to the 2x.
1 half e to the
E to the 2x.
2x. I know it's one. Final answer?
1 half x
X e to the
2x
2x
minus
minus
1/4
1/4
e to the 2x plus c.
e to the 2x plus c. That's it.
Hmm.
That's probably the hardest thing I will give you on the test. The ones like x cosine of x or x sine of x are even easier, because the derivative of sine and cosine is pretty tame. They don't get any bigger. They just sit and blink at you. Usually. Questions?
Nope.
All righty. Well, I've got good news and bad news. The good news is, well, no, I'll give you the bad news first. The bad news is that
It's harder.
we're going to hit the topic we were hitting last week in inverse trig function derivatives.
Oh, yeah.
I need to walk you through. Oh, sorry. Did I need this?
Oh,
Yeah,
yeah,
that's-
yeah, sorry.
Go ahead.
Right there, the big
Are the other ones okay? I'll just write it right
dx.
there. The good news is the note's going to take way longer than the assignment could possibly work. So you've got a day off of homework.
Yeah.
So go rest your brains for a little while. And by the way, you all are eligible to watch the video.
You can erase it now.
And oh, okay.
Okay, unless someone else is using it.
Yeah.
There's just a question about the videos.
Yeah.
Because like when I was in here on Friday, do you post them
I need to.
like?
They're not on the Google Meet folder.
So it's just on like your personal.
Yeah,
YouTube
it's
account?
right.
Correct.
Okay.
If you can get onto the Canvas page, there's a link to it. It's a YouTube videos.
Yeah.
Well, if you go into the archive videos, click on that. There should be a list of videos, and right on the top should be a link to the YouTube.
Or you just look up
If
on YouTube.
not, what's that?
Look up Brian Cochran on YouTube.
That's true, which there aren't many of us,
Yeah.
apparently. And I can also send it the link.
Okay.
Actually, I'll just send everybody the link.
Just for giggles.
Hey, I got my computer with me.
I subscribed.
Myself. Got it. YouTube link. Hi, y'all.
Hi.
YouTube.
It was long, but it was fun.
Was what?
Drive to Ohio.
Did you see a lot of family?
Yeah, I saw, oh my gosh. So my uncle, he basically lived in his house since COVID started, remember? His apartment. He was there, but he wouldn't go inside.
Okay, check your email when you get home, it's
He
there.
had an inside indoor mat. What it was a baseball cup on his face. Wrapped around the string, wrapped around his face. I could not stop it. Our family was like, making fun of him. So bad. It was so, this is indoor mask. He's an outdoor mask too.
Oh my god.
Yeah, it's so sad. Yeah. And then,
I'm one of my uncles, and he's like the most Catholic of my uncles, but he's so terrified of COVID. He like wouldn't come out.
Right.
yeah.
Let's try this. Does everybody remember how to do a problem like this? In last week.
Oh, yeah.
It's called a forward-backward problem.
That was,
It's a freak-out problem. Using trick.
oh, yeah, so we used to draw the trig shape and then place numbers in appropriate spots.
Right. The answer to a forward-backward problem is to draw a trig shape. 95% of the time it's drawing a right triangle. And the other 5% is drawing a unit circle. So pick any corner other than the right angle to call theta. The reason, if you remember, the sine of an angle will give you a fraction. The inverse sine, or any trig function, of a fraction should give you what? An angle, theta.
Yeah.
So if you notice, inverse tangent of 3/4, I have no idea what that is, but it's going to give me an angle. So just blinking at it for a second, it's going to be the sine of some angle. There's two different things that would have told us that. Taking the sine of anything, it has to be taking the sine of an angle. And taking the inverse tangent, or inverse anything, of a fraction should go back and find the angle. So definitely we need an angle somewhere to just put theta. Alrighty, so what would I do with the 3 and the 4?
So,
Yeah.
It's opposite over Jason, correct?
Correct, opposite of adjacent. So where would I put the 3?
Three would be on, that side right, on the right.
Okay,
Opposite theta, and then four would be on the side under the.
correct. So opposite theta, adjacent theta. Does that make sense? How big is this?
5.
It's 5, by the way. Congratulations on remembering that. The 3, 4, 5 is one of the most common right triangles in geometry. Can somebody find the sine of theta?
3 over 4, 5.
You're done.
That's so
Remember that? It's very slick once you get there. You know, even if there's radicals in it, you can get some really gross radical answers very quickly. Now, why did I bring that up?
Oh, no.
Glad you asked.
Uh,
Let's see. What is the derivative of the inverse tangent of x? Short answer, we don't know. Never seen this before. What do you call something you don't know? A variable, y or x or whatever. So in other words, inverse tangent of x, I don't even know what that is. I'm going to call it y. Now, I want to take the derivative. I can take the derivative of both sides. I'd get dy equals, I still don't know. So that's not going to do it. Inverse tangent is beyond my ability. Is there a way to get rid of it? Legally?
yes.
Or trig people?
10.
Take the tangent of both sides. That's basically, it's not multiplying by tangent, it's taking the tangent of both sides. Basically taking y and plugging it into tangent, taking this disaster area and plugging it into tangent. Cancel. So the tangent of y is equal to x. Now can you take the derivative? We did find out that no matter what icky thing you do to both sides, the derivative should not be affected. What's the derivative of tangent? Anybody know?
So what's cosine over, no, sine over cosine?
Actually,
It's
Oh,
remember? It's an elementary one.
Yeah.
secant.
Secant squared.
Yeah.
Secant squared of y dy equals what?
Dx.
Dx, or 1 dx.
Okay, it's still projected.
I agree, but can you get dy over dx? That will finish the problem.
Divided by d. Oh.
First of all, what would you get rid of? I want to get dy by itself. Divide by secant squared.
Could you divide by dy and then just flip flop? So one
Yes,
over,
you could.
1 over secant squared y.
Yes. And then I'm just going to divide by dx. Cancel, cancel. So dy over dx, yeah, you would have gotten secant squared of y over 1, and then just pull it right down, right? Equals 1 over secant squared of y. There's just one thing I'd like you to do. The original problem did not have any y's in it. It was our addition. Can you replace it?
Yep, understand.
Do for it. Yeah. It's 1 over, and you remember that this is really secant of y parentheses squared? This, the whole thing squared?
Yeah.
I'm going to write it like that. Secant of inverse tangent of x squared. What is that? Let's find out. Forward vector file.
Oh, wow.
Let's draw a rectangle. Now, it only works with a fraction though. Because you got to plug a fraction.
Maybe the x.
Yeah, you can do x over
1.
1. Perfectly legal. So here's theta. Where do I put the x and the 1 to make tangent make sense? What is tangent in the SOHCAHTOA world? Opposite over adjacent. So what's this? X, and this is 1. What's this? Pythagorean theorem. I mean, it's this squared.
It's 1 plus x radical.
Right. It's radical x squared plus 1, or 1 plus x squared, whichever you like. I'll do 1 plus x squared. That looks worse,
But I don't care.
it fits the a squared plus b squared a little better. So, what's the secant of that angle? Oh, math people, what does secant mean?
1 over cosine.
It's this, find the cosine for me.
Cosine is 1.
1 over
that.
radical. So what's secant?
Radical over 1.
Radical over 1.
So just
So it's basically, it's 1 over radical
1 plus
1
x squared.
plus x squared, or 1, parentheses squared. Square that bottom for me. It actually becomes very
Oh my
nice.
gosh, this is 1 plus x squared.
Uh-huh.
Then you bring it up top.
And then how do you divide by the fraction? You multiply by, well, what do you do?
Well, divided by 1 is just 1. But yeah.
And then, yeah, ta-da! So you've got 1 over 1 plus x squared. That is your derivative of inverse tangent. Doesn't even have a radical in it this time.
That's nice.
Kind of exciting. Okay, we have more notes tomorrow, so no homework for Joyce. Be glad to go pass a humanities test or something. And that'll do it. So, Emma, nice to see you virtually, and God bless. Talk to you soon.